Okay, members, we have the next question here. Let us go through it. It's a bit wordy, but it's very easy. So they say a football player projects a ball at a speed of 80 meters per second at an angle 30 with the ground. The ball strikes the ground at a point which levels with the point of projection, and after the impact the ball bounces and the horizontal component of the velocity remains the same, but the vertical component is reversed and halved in magnitude. The player runs after the ball and hits it again at a point which is a horizontal distance of 1 meter from the point where it bounced, so that the ball continues in the same direction. Find the horizontal distance between the point of projection and the distance which hits the ball. So let us do this question. Let us sketch it. So we are having someone, this is our ground. So we are going to assume this is going to be our ground here. Our level ground of the field. Okay. Now someone is striking a ball like this. It will come, then it will bounce. Then after, it bounces again. So now, we start if this is our initial, and then us that it is striking it at a velocity of 8 meters per second, and then at an angle of 30 degrees. So they are giving us this at 30 degrees. Continue reading. Levels with the ground. So, and which levels with the ball strikes the ground at the point which levels with the point of projection. So if this is the point of projection, it's going to bounce there. And after the impact, the ball bounces and the horizontal component of the velocity remains the same, but the vertical component is reversed in direction and halved in magnitude. The player runs after the ball and hits it again at a point which is a horizontal distance of 1 meter from the point where it bounced. So, this player is going to be from 1 meter where it bounced. So we are going to assume this is going to be our 1 meter. Then this player is going to come and then strikes the ball again from where it bounced. There they are giving us 1 meter. The player runs after the ball and hits it again at a point which is a horizontal distance of 1 meter from a point where it bounced, so that the ball continues in that direction. So it's going to come back and it's going to hit it again there, so that it continues in that direction. Now, from there, what are we having? They're asking us horizontal distance between the point of projection and the point where the ball is hit. Then this is going to be our, they're asking, simple terms, they're asking for the range, this range. And he said when we will be at the range here, it means that the displacement we are covered is 0. And we saw that our range is given by u squared sine 2 theta over d. Now they are telling us that taking b to be this. We saw how we are deriving all these things here. So from that, it means that now this range I'm looking for, this is part A. So my r is going to be, now u, the initial velocity, this one is our u. It's going to be 8 squared, then sine of 2 into 30, then the whole divided by 9.8. So our r here, that distance is going to be they told us to take our gravity as 10. So taking gravity as 10, let me get it, that's not clean this. Okay. Now here, they give us our gravity as 10. And then when you press that on the calculator, you always be careful when they give you the calculation of force there. So here, when you press that one, you get 5.5426 meters. So now this is the distance between this and then where the ball bounced. As simple as that. Part B, they are asking us, B Roman numeral 1, the time interval between the ball striking the ground and the player kicking it again. The ball striking the ground here and is kicking it again here. So now this one means that for this one, kick it again, you would have covered this distance of 1 meter. So in simple terms, from our S equaling to UT plus a half AT squared, now you want this distance, our SX, the horizontal distance here, that is going to be covered. Our U is going to be UXT. Then instead horizontally, then our acceleration is going to be 0. So here our SX is going to be UXT. But our UX, remember our UX. So this horizontal ground that this man is going to cover between where it's starting the ground and then where it's sit is 1 meter. So one is going to be, remember our UX is given by U, and then cos theta. So this one is going to be U cos theta, then T. So one is going to be our U, the initial. Of course, now this one is telling us that the speed change, look at this. But the velocity, the impact the ball bounces and the horizontal component of the velocity remains the same. So meaning that our horizontal component there remained the same, but the vertical component was reversed and half. So our horizontal component starts here. So remain, they're telling us that this horizontal component remained the same. Let me show you there that idea. Okay, now from here, our vertical component, and then our horizontal component is going to be our U is 8, then cos our theta was 5 degrees. So notice that this one remained the same, it did not change. So putting it here, now I have 8 cos 30 degrees T. So my T here is going to be now 8 cos 30. 1 divided by also. So here I'm getting 0.1443 seconds. Now it means that when this man is striking the ball again, the time that it develops, because this man had covered this distance, means that the ball had covered this distance. So, meaning from here up to here, the time that had elapsed to cover and hit it again, it was 0.1443 seconds. Then B, Roman numeral 2, they're asking the height of the ball above the ground when sit again. So the one they're asking for this height here. This height here is Y. So still using our S equaling to UT plus a half AT squared. Remember, they told us that when after bouncing, remember here, after bouncing, the vertical component is reversed in direction and halved in magnitude. Now, halved in magnitude, we first get our horizontal component. Our vertical component, which is UY, or it is going to be U, then sine theta. So now, this one, after bouncing, it was reversed in direction. So let me call it U line. For it was reversed in direction. This is so that it was reversed in direction and halved. So halved, it was halved. So now, after that, so meaning our U prime here is going to be now negative U 8 sine 30 degrees over 2. And this will give us the U after the ball bouncing as negative 2 meters per second. So now meaning, here when I'm getting my vertical component, I'm going to say now Sy is going to be U prime Y of T, then plus, because it's going to be, acceleration is going to be negative, then minus a half, okay. A minus a, okay, let me define this, G, Okay, if I put t, then this is minus, then minus t squared. So now the time to cover this height is going to be the time we put here, then hour is going to be this which we are going to use in there. So now we are asking for this height. So sy is going to be this, which is, now you see it's negative 2 in magnitude, so meaning when you take it there, it's going to be now negative 2 into t, which is our t is what? 0.1443, then minus a half, 10 into what? 0.1443. And so here our sy is going to be, can we compute this? Okay, so we compute that, we are going to be having, now you see the answer, you just press the calculator there, as you can see there. So now when we are dealing with this, it means now this sign, it was just showing us that it was changing the direction, but this sign now when we are calculating, we don't include it there. So now remember here it was a square, our t was square. So here the answer after pressing that, as you've seen, is going to be 0.1845 meters. So this is the distance, this is the height that this ball is going to be hit at when that bowler wants to hit it again. So basically that's it there. So that's it there. So, unless otherwise, I wish you well.